that I bring you Rad Travis Wright. For those who don't know Travis, if you want to know anything about Service Manager, this is one of the guys you definitely need to be keeping a close eye on. He does a lot of great stuff. He's worked for Microsoft, working for CyrusSend at this point in time. And note, I said the company name properly for a change.
Way to go,
I worked on that forever.
Way to go.
All right, with that, I will hush up and let Travis take the mic as we get ready to roll.
All right, thank you, Cameron. All right, so do you guys have my feed? No. All right. Yes.
Oh, it should be in the
okay, let's try
the answer
duplicate.
is Pete Zerger. Pete Zerger is the correct.
How about now?
And then the one before that was...
There we go. We're good. Good? Okay. Ready to go? All right. Excellent. Well, thank you for having me here to System Center Universe again. This is actually my third time. I was here for the original one back when I lived in Austin, so I just actually drove to the first event. But glad to be here again. You know, as Cameron mentioned, I was at Microsoft for 11 years working on System Center as a PM there, and System Center is my love. It's my life. It was hard to leave Microsoft recently, but I did to join a company that is a partner in the System Center community, specializing around Service Manager called SCSM, and it's been great to just have a change of pace and get back to product development and things like that. And so, you know, I'm here in a different capacity this time, but you know, it's all about the community. And so today, this presentation will just be, you know, just kind of cool stuff around Service Manager. And you know, one of the things I want to talk about is just you know, there's all these acronyms I want to cover today. PS, WF, SMA, WAP, SCSM. What are these things? And so we're just going to talk about how all these things can come together to, you know, at the end of the day, it comes down to impressing the boss and getting a promotion. And you know, it's kind of funny. I'm glad that I thought about doing a superhero thing like Kent did. I'm glad I didn't, because that would have been awkward. So what I'll do instead, because I decided not to do that, is I'll be superhero's alter ego Clark Kent by putting on my glasses. There we go. And you know, I did bring a superhero with me though, IT Monkey with his cape. So there we go. So we'll just set IT Monkey over here. He'll be my co-presenter today. And we'll learn how to implement all of these acronyms, these letters together to you know, impress our boss and get a promotion. So if you think about it today, you know, there used to be this term, a pencil pusher, right? This is somebody, you know, back, you know, a couple decades ago, probably at this point. And that was somebody who had a, you know, kind of a boring, you know, kind of meaningless job. And all they did was maybe, you know, sign things or check off boxes or, you know, just keep track of paperwork. And, you know, in today's kind of more modern society, especially in the IT world, we still have people like that. And I call them button pushers. That's all they do all day long, is they just sit there and push buttons. And you know, it's like I could get a Carl to do that for me, right? I could get Carl out. I could get him to push a button for me. That's not really a big value add, and IT people are generally pretty expensive. And so, you know, what we want to do is we want to look at how we can take these, you know, IT people, and instead of having them just sitting there pushing buttons, let's automate the boring parts of their job and get them doing something more interesting, more fun, and adding more value to our organization. So that's what we're going to talk about today, is kind of how to automate some of the boring things. So I love this quote by Don Jones, one of the PowerShell MVPs. Maybe some of you guys have heard this before. Learn PowerShell or learn the phrase, would you like fries with that? You know, because you're going to end up working at everyone's favorite cheeseburger restaurant. And then maybe some of you have seen this presentation that Jeffrey Snover did. Jeffrey Snover is the Windows Server architect, father of PowerShell, one of my most favorite guys at Microsoft. He did this great presentation that talks about blue-collar IT versus white-collar IT, and he said that basically what's going to happen over time is that, you know, either people are going to be automated effectively out of a job, and they're going to be the ones that are kind of doing the manual labor of IT, if you will, kind of the guy that's going around in the dark in the server room pulling out the hard drives that have a red light, you know, or you're going to be more of a white-collar IT person. That's the person that's actually creating that automation and really driving things forward. And so today I want to talk about, you know, PowerShell and automation and things like that, and how this is really a big value to the organization. We can lower our costs through automation. We can reduce the time to completing things. We can minimize human error. And one of the things I've been thinking about recently is this kind of idea of abstracting away high security operations. So today, I mean, a lot of you guys can probably relate to this. IT people have pretty high privilege accounts. They can go out there and they can do all kinds of crazy things on the systems. That's probably really not the best thing to do from a security perspective. You know, if somebody were to go rogue on you and kind of try to take down your systems or something like that, that's a big risk. And so what we can do is we can use process backed by automation to abstract away those permissions. So somebody can still request to do something. It can go through a process, maybe be approved first, that kind of thing. And then it's implemented through automation. And the automation runs as that high security account. So something to think about as another value of automation here. So what I want to do now is I want to introduce PowerShell workflows. So, you know, every conference I go to where I talk about PowerShell, I ask this question. How many people would consider themselves proficient with PowerShell? Just raise your hand. Proficient. Okay, a few. Okay, good. So what I'm seeing, you know, over time is that more and more people are sort of getting on the PowerShell bandwagon. They're learning PowerShell and, you know, seeing the benefits of doing that. So today what I want to talk about is PowerShell workflow. And PowerShell workflow is a little different than the PowerShell that you might be using kind of on a daily basis. So PowerShell scripts and commandlets and things like that are basically the same type of thing as a PowerShell workflow, but a PowerShell workflow is a little bit different. PowerShell workflows they're actually basically like a script that gets compiled into a Windows Workflow Foundation workflow at runtime. And so it's compiled code that's executed. And so it's really fast. You can do some interesting things with PowerShell workflows. You can suspend and resume workflows. You can run commands in parallel. You can run you can run regular PowerShell scripts and things like that inside of an inline script block. One of the nice things about PowerShell workflows is that it can survive operating system reboots and network outages. So when you run a PowerShell workflow, it'll sit there and wait until the network comes available again, and then it'll go out and do what it needs to do. Or if the computer gets rebooted, it can be sent into a persisted state, and when the computer comes back up, it can continue. So there's a lot of really cool things about PowerShell workflows that are pretty powerful. And especially when you're looking at automating processes, right? These are things that are going to be running in the background. Nobody's going to be sitting there watching them like you would if you executed a command from a PowerShell window. So you want your PowerShell workflows to have this kind of resiliency to be able to execute even when the operating system reboots or the network is out. So just as a way of introducing PowerShell workflows, you've got the standard hello world example here. So when you declare a PowerShell workflow, you just use the workflow keyword to declare it. You give it a name. You open curly braces, and then you tell it whatever you want it to do. In this case, I just told it to output hello world. Super simple example, right? And you can see that the syntax is basically the same as anything else that you would see in PowerShell. We can also execute PowerShell workflows remotely. So I can, now that I've declared this hello world workflow, I can now pass the PS computer name parameter and actually tell that workflow to run on a remote computer. So that's pretty powerful. We can also do run as. So in this case, we get a PowerShell credential, and then we can execute it as a different security context. So that's obviously really important when you're doing automation because you want to probably oftentimes elevate the privilege to do certain actions, or depending upon which system you're touching, you may need to use different credentials. And so this is a very important part of workflows. And we can execute PowerShell workflows as jobs, and the advantage of that is that we can execute them and then kind of forget about them and leave them off to the side, and then we can come back and see if they're done or not, what their status was, what their output was, and PowerShell will just keep track of all of that for you. So in this example here, I run hello world, I pass the as job parameter, that gives me back a job ID, and then I can do get job ID, or get job, and then pass the ID. So that way you can see what the current status is, what the output was, and so on. Now we can also retrieve the output of a job. So PowerShell keeps track of all of the output that comes out of that PowerShell workflow, stores it in the PowerShell infrastructure, and then we can receive the job, pass in the job ID, and then get the output of whatever came out of that. So it kind of handles all this logging for us, which is really nice. Now you can also author these PowerShell workflows inside of the PowerShell ISE. So just where you would author your PowerShell scripts and that kind of thing, use the exact same tool to author PowerShell workflows. So here's an example of authoring a PowerShell workflow that calls the get process activity. So one thing to note is that anytime you run something inside of a workflow, you're actually executing a PowerShell activity. which is basically underneath the covers of Windows Workflow Foundation activity. So it's not executing a PowerShell commandlet. You can convert a PowerShell commandlet to a PowerShell activity using a class library that Microsoft provides. You can actually take an entire module, run it through this tool, and it'll output PowerShell activities for every commandlet that you have. But it's something that's important to note. You can pass parameters in. So just like you do with a PowerShell script, exact same syntax and everything, you can define parameters that are passed into the PowerShell workflow. And that way, and this is key for automation because you want to be able to pass in variables so that it does things differently each time depending upon what the request is. You can create, they can be data typed, they can be mandatory or not. And one kind of quickie, thing that I ran into is that if you have a parameter name which has a hyphen in it, it has to be enclosed in quotes. A little trick for you there. That actually got me hung up for a little while. Now, I mentioned earlier this notion of the difference between a commandlet and a PowerShell activity. If you want to run a commandlet, then you just need to put it inside of an inline script block like this. So in this case, get process is using the get process commandlet. So up here, we were using the get process activity that comes out of the box because it's not inside of an inline script block. And down here, because it is inside of the inline script block, we're using the get process commandlet. And if you want to do any sort of piping and things like that, you need to do that within the context of an inline script block. Now, one important thing about PowerShell workflows is that you can persist state. So a persisted state basically takes all the values of the variables, persists that to disk, persists the point at which the workflow is running at, and keeps all that information on disk. And then we can retrieve it back later and execute it. And we can do a checkpoint in a number of different ways. We can use the -ps persist parameter either when we call the workflow to persist the entire workflow at every point after an activity completes. We can call -ps persist after each activity call, and we can persist after that particular activity. And we can also use checkpoint workflow activity to checkpoint the workflow at a particular point in that workflow. So this gives us a lot of flexibility. So for example, if we wanted to run a command, have it execute, and then we want to checkpoint, and then we wait for a while, like maybe we want to wait for some other thing to complete, then we can restore it after like a sleep or something like that, bring it back up and go forward. Yes? Yeah, the inline script block. So if you've got something inside of an inline script block, you can't persist within that inline script block. You'd have to wait until the inline script block completed, and then you could put in a checkpoint workflow activity. Yeah. Okay, so the next interesting thing about PowerShell workflows that you can't get with regular PowerShell scripts is the ability to do things in parallel. And there's two types of ways to do parallel. The first is a for each command. And so in this case, the first command here runs for each. And what I'm doing is I'm just passing a list of computers and pinging them using the test connection activity. And then in the second command, I do for each -parallel. And what happens in the output that you can see here is in the first case, it goes through and it pings the SCSM computer 4 times. And then it pings the DC computer 4 times. And then it pings the SQL computer 4 times. In the second set of output where we're doing the for each parallel, you can see that it pings SQL, DC, and SCSM all at the same time, pings them all again at the same time, pings them all again at the same time, right? So now one thing to keep in mind here, though, is that the order of what happens here is non-deterministic. So anything that's run inside of a for each parallel block, you don't have any control over which order those commands run in. So that's something to keep in mind. And then the other thing to keep in mind is that the max degree of parallelism for the for each parallel block is 5. So it'll basically spin up 5 threads. It'll go do those 5 things simultaneously, and it'll do the next 5 and so on. The other way to do a parallel is to use the parallel block. So the parallel block is just a keyword. You put everything inside of some curly braces. So in this example, we can see here that I've got command 1, command 2, and then I use a sequence block. And the sequence block will obviously execute each of the commands in sequence. And in this case, it calls start sleep and then command 3, and then command 4 is the last command in the parallel block. And so the output, as you would expect, would be command 1, 2, 4, and then 3 because of the sleep that happens inside of that sequence block. So using parallel and sequence together, you have a lot of flexibility in terms of how your code executes. Okay, and then I think this is the last example is suspend and resume. So this is an example where I'm going to suspend the workflow, and then I'm going to retrieve it back out of the job history and resume it, and then it'll complete the action. So to do that, I'm just going to show you a quick example of this. So here's the PowerShell workflow here. And you can see that in my target folder here where this file is going to be copied to, it's currently empty. So what I'll do is I'll just execute this command here. And you can see that it gives me back a job ID of 14 here, right there. And so what I'll do now is I'll call a command, resume job ID 14. And now it's running. If we go over here, we can see that the file has in fact been copied over. So that's an example of how we can suspend and then resume a job at some later point. All right. So now what I'd like to do is introduce service management automation. So service management automation is a new capability that's provided in System Center 2012 R2. So it's pretty new, right? I mean, System Center 2012 R2 just came out in October. So this is a brand new technology. Anybody tried SMA yet? Christian, I love you, man. My one man over here. Yeah, SMA is behind Service Manager. It's my new love. It's like Service Manager, SMA, and then Ops Manager. So SMA is a PowerShell workflow-based automation platform. It's similar in its purpose to Orchestrator in that it's designed to be used for automating IT processes or systems and so on. But in the case of Orchestrator, it has like kind of a proprietary, if you will, workflow engine. And then with SMA, it's a PowerShell workflow-based engine that's all built on Windows Workflow Foundation. The interesting thing about it, though, is that you actually install SMA as a component of the Orchestrator setup. So you go into Orchestrator setup, you'll see down at the bottom that there's a couple links there to install SMA. And SMA provides for the ability to use any type of PowerShell module, right? So you can go out there and, there are literally hundreds, if not thousands, of PowerShell modules, and then probably, tens of thousands or more of PowerShell commandlets that are out there, both from Microsoft as well as third-party vendors. Like I just found one on Amazon the other day, as well as like community solutions and so on. And you can import any of those PowerShell modules into service management automation to take advantage of all the commandlets that are in there as activities inside of PowerShell workflows. So with Orchestrator, you get like maybe these 20 or so integration packs, and that's great for things like System Center, and they have like Exchange and AD and so on. But you get a lot bigger selection of activities if you were to use the PowerShell activities. Now, some other advantages of SMA over Orchestrator is that it supports 64-bit. It's a native PowerShell execution instead of kind of the way that Orchestrator does it, which is not exactly what I would call native. It supports PowerShell 3+. You can checkpoint and restart your runbooks, as we talked about. You can save your drafts. You can version your runbooks. You can schedule them to run without using like a scheduler activity and so on. You get the parallel processing support from PowerShell workflow. And so there's kind of a lot of advantages to using SMA versus Orchestrator. Not that Orchestrator isn't good. It's got its great qualities as well. But these things with SMA I think are interesting to note. And then one kind of key difference between SMA and Orchestrator is the runbook designer. So the Orchestrator runbook designer, as I'm sure all of you have seen before, is kind of a drag, drop, and configure experience. The SMA runbook designer is more of a text editor with support for IntelliSense, if you will, and that kind of thing, which I'll show you here in a moment. So it kind of depends on what your preference is. For me personally, I can write workflows faster in SMA just because I'm very familiar with PowerShell, and for me just to type stuff is faster than me being a button pusher, if you will, and dragging and dropping and doing all that in Orchestrator. So it's kind of a personal preference thing for now. I'm constantly pounding on Christian to get them to build a visual designer for SMA, so hopefully we'll get that hooked up here pretty soon. We'll see what happens. So as far as the architecture goes for SMA, there's the underlying infrastructure, as we've talked about, is Windows Workflow Foundation. On top of that is PowerShell. Then you have the Service Management Automation Runtime, which is where all of the runbooks are executed. And then you have the Service Management API, which is a set of web services that sit up on a IIS website. And then out of the box, SMA provides some PowerShell commandlets that you can use to manage SMA itself. Like, for example, you can invoke a runbook using a PowerShell commandlet. You can import runbooks, export runbooks, and so on using those PowerShell commandlets. And interestingly enough, the SMA user experience is exposed through the Windows Azure Pack admin portal. So we'll see that here in just a moment. Now, it's also possible to integrate Orchestrator and SMA together. So as I mentioned, SMA comes with these PowerShell commandlets for SMA. So you could have inside of your Orchestrator runbook a PowerShell activity that invokes a runbook in SMA. And you could do the reverse, too. You could have a SMA runbook which invokes an Orchestrator runbook. So kind of some interesting possibilities there that would be very interesting to think about as you're maybe migrating from Orchestrator to SMA. Okay, so now I want to introduce Windows Azure Pack. How many people have tried Windows Azure Pack? Also new, right? This came out in October. Okay, Christian, dude, I love you, man. Yeah, so Windows Azure Pack just came out in October, along with System Center 2012 R2. Windows Azure Pack is basically think of it as a portion of Windows Azure brought on-premise to run in your own data center. Or it's also designed in a way that service providers can install it and expose those types of services to their customers. So it provides an infrastructure for hosting websites, hosting databases, either SQL or MySQL, hosting application development services like the service bus, and it's the same service bus that you would get in Windows Azure, but it's running on-premise. You can host virtual machines, of course, and you can also create virtual networks. So on top of the Windows Azure Pack, there's a Service Management API layer, and then on top of that, there are two portals. One is an admin portal to configure Windows Azure Pack, create subscriptions of different resources that people can subscribe to, and then there's a tenant portal where people can sign up and consume those subscriptions. So this is the architecture of Windows Azure Pack. There's a Windows Server underlies everything. Hyper-V, of course, is the hypervisor layer. It's built on top of IIS for hosting websites. It's built on top of SQL Server for hosting SQL Server databases. The service bus is there. And then kind of this key component of all this is that there's this platform as a service provisioning and management engine. And that is the same management engine that is provided in Windows Azure. They're just bringing it down and running it on-premise. And then a lot of the other components of the System Center suite, like Orchestrator and Operations Manager and Virtual Machine Manager, play a role in exposing all of these infrastructure pieces as services through that Service Management API to those portals. Now, the interesting thing about this is that this is really kind of at the heart of Microsoft's Cloud OS vision. So Microsoft's Cloud OS vision is to, we kind of started, I say we, I still have this mindset that I'm at Microsoft sometimes, but Microsoft started with building out the private cloud infrastructure with System Center 2012. We've got Virtual Machine Manager, we've got Hyper-V, we've got kind of the rest of the System Center suite around that, providing different services. And that was kind of the private cloud era. At the same time, Microsoft was creating Windows Azure, and now we can sort of think of that as the Microsoft cloud. And then service providers were also setting up Hyper-V-based infrastructures to offer their services, and they've been offering IIS websites and SQL Server databases as services for a long time. But now what Microsoft has done is they're trying to unify this cloud operating system across all of these different types of clouds by providing this one consistent platform. And this one consistent platform is basically taking elements of Windows Azure and bringing those to run on-premise either at a customer's enterprise data center or at a service provider's data center. So there's this one consistent platform across all these different clouds for managing virtual machines and other services like databases, websites, and application development services like the service bus. And at the same time, technology that has maybe more historically been kind of an on-premise technology like Hyper-V itself is being brought up into Windows Azure. So Windows Azure, I don't know if you guys know this, but it used to be its own sort of branch of the Hyper-V code. Well, now in Windows Azure, it's running the Windows Server 2012 R2 Hyper-V version. It's the exact same version now. So some of that technology has historically been on-premise, is going up to Azure. Some of that technology has previously been in Azure, is now coming down on-premise. And we get this one consistent platform going across all of these different locations. All right, so with that, I'm just going to do a quick SMA and WAP demo, just to sort of give you guys a feel for what this looks like. So this is the WAP admin portal here. And so this is where an administrator would come in. They would configure their website clouds. This is where they would say, here's my pool of IIS web servers that I want to use to host my IIS websites. I've got VM clouds, which is managed by Virtual Machine Manager. I can identify a bunch of VM hosts, and that's where I want to provision my virtual machines. I can do Service Bus clouds, SQL servers. I can indicate which SQL servers I want to use to host my customers' databases. MySQL, same thing. And the one thing that I kind of want to spend a little bit extra time here on is the automation tab inside of the Windows Azure Pack admin portal. This is where we configure the SMA runbooks and monitor their activity. So we can see here that we've had the new employee runbook executing multiple times recently. We'll actually see that as part of a demo later. So this is our dashboard, so we can see the execution of these runbooks over time in kind of a graphical way. And here's where we can manage our runbooks. So you can see that there's a number of runbooks that are imported out of the box. And I've created some in here myself for demo purposes. And then lastly here is the Assets tab. So the Assets tab is where we can import any PowerShell module, and it will automatically create PowerShell activities for us out of every PowerShell commandlet in that module. So down here, you can see that we've got this import module button. We click that, we point to a module, it imports it, creates all those activities for us. And so you can see this list of modules that come here out of the box. And we'll see in a little bit later. I mean, out of the box, you literally get hundreds of commandlets. I don't even know how many it is. And then you can import any other ones that you want from Amazon or VMware or any other, sort of PowerShell module you can think of. All right, so that's just kind of a quick tour of SMA and WAP. And the next thing I want to do is just kind of quickly cover off System Center Service Manager. How many people are using Service Manager today in production? Okay, good. Probably about 10% or so. So for those of you that maybe aren't as familiar with System Center Service Manager, I do want to cover that really quickly. Service Manager is, first of all, a platform. It's a platform that includes a number of different kind of infrastructure capabilities. So it's got a configuration management database, or CMDB, to store everything that you manage. Could be Windows servers, could be Linux servers, could be mobile devices, could be printers, could be network devices, could be application service components like a database or a website. You can store anything you want to in there. And it's extensible. You can add additional types of things that you want to manage in there. It also has a data warehouse for long-term storage of data and reporting. Has a workflow engine. Has a .NET API for being able to interop with Service Manager. And then it's got a notification infrastructure for sending out email notifications. It's got a .NET console that has customizable forms. And it's got a security model that helps you secure all the data inside of your CMDB. On top of this platform, Microsoft out of the box provides a number of IT service management solutions for things like incident and problem management, service request fulfillment, change management, knowledge management, a service catalog, so kind of all these different solutions that come out of the box for IT service management. And then they also provide some connectors to Operations Manager to bring in, for example, alerts from Operations Manager and turn those into incidents inside of Service Manager. You can bring in all of the discovered inventory the Operations Manager finds into the Service Manager CMDB. It's got a connector to Configuration Manager to bring in inventory. It's got an orchestrator connector to automate things via orchestrator, an integration with Virtual Machine Manager to bring in all your virtual machine inventory, and a connector to Active Directory to bring in users, groups, and computers, and an Exchange connector to automate kind of the mail flow around IT service management. That's a quick overview of Service Manager. Hopefully most people are familiar with that, but I do want to kind of just make sure we have a baseline for that. Now we get to the interesting part. which is where we integrate Service Manager with SMA to automate the various scenarios around IT service management. So one of the interesting scenarios that we can automate around IT service management is the fulfillment of our, or management of our IT processes. So similar to what we could do with the orchestrator integration of Service Manager, we can put an activity work item in the process of one of our work items inside of Service Manager. So for example, if I had a service request, as we'll see later, to onboard a new employee, I could have my approval activity in there, and then I could have an SMA runbook activity in there, so that when the approval activity is completed, the SMA runbook activity will get kicked off, and it will automate the fulfillment of that request to onboard a new employee. So that's an example of how we can automate the IT process around employee onboarding. Another example that we could have is where we trigger SMA runbooks as part of a subscription workflow in Service Manager. So I could subscribe, for example, to any type of object being created in the Service Manager database or any type of object being updated. So an example of that could be, if I get an incident where the classification is server down or something like that, maybe it comes in from Operations Manager, I could, for example, trigger a SMA runbook to attempt to repair that computer. Maybe it starts by pinging it, maybe it tries to do a wake on LAN, or whatever, to try and resolve that incident automatically, and then call back into Service Manager and update the action log on that incident to indicate what was done to try and bring that server back. So there's a couple key scenarios there that we can do to integrate Service Manager with SMA. So to do this, we would want to have some SCSM workflows that integrate with the API via the PowerShell modules. And then we would also want to have some user experience within the Service Manager console that can also interact with SMA via those same PowerShell commandlets. So those PowerShell commandlets are basically our interface into SMA. And then it would also be convenient if within the context of the Service Manager console, I could click a link and go back out into the Windows Azure Pack admin portal in context to that particular runbook and see what the status of that runbook job was. So I'm going to do a couple more slides here, and then we'll kind of wrap up on a demo. So out of the box, Microsoft provides a self-service portal. And a self-service portal is what you want to expose to your, let's call them customers, okay? I don't like to use the term end user because this portal could just as effectively be used for people within your IT department to request IT services. So that, an example of that would be like where the database team is requesting something from the network team, for example. So this self-service portal is not intended just for end users to request things like my laptop's broken, but it could also be used for kind of IT to IT requests. So let's call them just generically customers that we're trying to expose this to. And so when we expose this to our customers, we want to expose to them a service catalog, which allows them to make service requests, like, hey, I need a port opened on this firewall, for example, as well as to be able to report incidents, like my laptop's broken. We also want to enable people to view and update their requests themselves in a self-service way. This minimizes the amount of time people spend on the phone or shooting emails back and forth to each other, like, hey, is that port open yet? That kind of thing. They can just go up to the portal and see if it's done yet. Also, we want to capture all the knowledge in our IT organization and make that available for people to search, as well as make it available in context to a particular request that they might want to make. And then we also want to provide the ability for people that are in a role where they're approving things to be able to come up to this self-service portal, approve them, see what it is that they're approving, and so on. And then also, if somebody has some work that's assigned to them that we're tracking via Service Manager, we want to allow them to update those activities that are assigned to them and indicate what they've done, is it completed or not, did it work or not, that kind of thing. Okay, so with that, we're just going to wrap up here on a demo that kind of brings this all together. So it's a lot of content. I'm speaking very fast because they only give us 45 minutes, but hopefully when we see it kind of all come together in the demo here, it'll kind of make sense. All right, so let's start here in a let's see. So we're going to start here in a custom portal that we built on top of Service Manager as a self-service portal. And here we're seeing the service catalog that I mentioned earlier. And so we're exposing here the request offerings that are defined in Service Manager. These are the things that people can request. And so we see a bunch of different options here. We would, of course, want to make these requests available to people depending upon their user role, and make it easier for people to find these requests and so on. And in this particular case, we've got our onboard new employee example here. And we'll just dive into this request offering here. And we can see here the request offering overview and instructions. Over here in the middle here, we have links to knowledge articles that are related to this request offering so people can get additional information. And then over here, we have information about the service offering. So this would include things about, what's the SLA around this particular type of request, what's the cost of it, and so on. And depending upon what we have configured here, we can either open a knowledge article from the Service Manager database, or we can link off to an external knowledge article that might be on our intranet somewhere. So let's go ahead and fill out the form here. And one thing we can do here is we can create a request on behalf of another user. So I'll just create it on behalf of this test user 2. And then let's onboard IT Monkey to our company today. He's passed the interview process, shockingly. He did bring some bananas. I think he basically bribed everybody. So let's give him a $500,000 a year salary, and he likes to take vacations a lot. I don't know if you guys know this, but IT Monkey, we hand him out at conferences, and then people go and they take pictures of him all over the world. Oh, dude, banana, nice. Awesome. Thank you. That was not staged. All right. So IT Monkey, you have a little snack. So yeah, he goes all over the world, and people take pictures of him and post them on Twitter. IT_monkey, if you want to follow him. It's kind of interesting to see where he ends up. Like Dieter had him on a motorcycle road trip with him in Europe to SCU dock in September. So let's give him a lot of vacation days. We'll give him 200. We'll set the priority of this as high. And then we can choose to, kind of order up some hardware for him. So we'll save this request here. And so this will be SR11606, right? So that's now a service request which has been created in Service Manager. And we can see that now shows up on my request here on the portal. I could go and view the status of it from here, update any information that IT requests for me, and so on. So let's go over here and look inside of the Service Manager console at what this looks like. So here's the new request that we just created. And what I'm going to do, just in the interest of time for the demo here, is I'm going to go ahead and approve this, and then we'll take a look at this while the approvals are processing. So one thing that you'll notice here is that because IT Monkey's salary at $500,000 a year is above the normal for monkeys, normally we pay them in bananas, so we have to get approval. So we check that off on the box, and so the line manager should review checkbox here is checked. So we can see how we can map these responses that the user provides on the self-service portal into properties, on the service request. Okay. All right. So while that approval is processing, let's go back over here to the service request general tab, and we can see that the affected user was test user 2 because I was creating it on behalf of another user. And the title and description properties here, this comes from the template that's behind that request offering. So every request that's made based upon that request offering will have the same value for template or for title and description. The urgency and source also comes from the template, but the priority, as I chose on the portal, as high is reflected here on the service request form. And then down here in the user input section, we can see all of the values that the user provided in kind of an at-a-glance view. And then what I want to show here is, at this point, you can see that the review activity is completed and the SMA runbook activity has been kicked off. So let's look at the SMA runbook activity here while it's processing. We can see that it's invoked successfully down here. Sorry, I'll try to zoom in so you can see it a little better. And over here on the Runbook tab, this is where we can see how the values have been mapped in from the user's response to the input parameters on our SMA Runbook. So for example, here's the start date that the user provided, and it's mapped to the start date input parameter on the SMA Runbook. And then down here, we can see his 200 vacation days were mapped into here, and his compensation, for example. So this is how we kind of pass information that the user provides to us on the self-service portal into this SMA runbook activity, and from here, it's passed into SMA to execute the runbook activity. So let's now kind of take a look at a couple quick examples of some integration into the user experience here. So I can click on this View Runbook link, and this will take me over to the Windows Azure PAC portal in context to the new employee runbook that I created. So in this example, the new employee runbook, let's just look at what this does. So the new employee runbook has these input parameters for employee name, location, vacation days, compensation, and start date. And then I tried to just put together some examples of the types of activities that you could use inside of a PowerShell workflow. So the first one here that we have is invoke SQL command. An invoke SQL command is an out-of-the-box activity you get with the SMA. And it just calls out to SQL and inserts some data into the employees table in the HRDB. New AD user here is a PowerShell workflow that I created that uses the Active Directory activities to create a new user in Active Directory. And then I've created another PowerShell workflow runbook called Create Incident that uses the Create Incident commandlet from SMlets, which is a PowerShell module that I created. It's out on CodePlex. You can download that, and you can import it into SMA. That's how I got this to work here. And then there's some other activities down here for doing things like writing to the event log. We use the out-of-the-box PowerShell module here to go and get the Active Directory connector and start that in Service Manager so that it syncs in that new user that we created in Active Directory. So let's just quickly see if our PowerShell if our PowerShell workflow is working. So we can see here, here's IT Monkey in our HRDB. And let's see, oh yeah, AD. So we go here to get AD user, IT Monkey. There we go. IT Monkey is created in our database. And if we were to go into, I don't know, we'll skip some of the, well, let's go here. We'll go to the Service Manager console, and we'll refresh the connectors view. We can see that the Active Directory connector is running. And the last thing it does is it puts an event into the Windows event log, and we can see that it's written in there that it's completed. So this is just kind of a quick overview of kind of how you can integrate service management automation with Service Manager. And I'm really excited about the possibilities of this. It sort of reminds me of the days when we first put out the orchestrator to Service Manager integration and how excited people got about the possibilities of what they could automate. And now I think the possibilities are much more expanded now because of the introduction of SMA. And the main reason for that is because you get the library of all of the PowerShell commandlets that are out there that you can use as part of your automation. You don't have to go through the process of trying to create an orchestrator integration pack and write the code or drop into PowerShell activities a lot inside of your orchestrator. Almost everybody's orchestrator runbooks that I see, they always drop into a PowerShell script activity anyway. So you might as well just do everything native in PowerShell workflow. So hopefully that gives you kind of a good idea of the possibilities of how you could integrate PowerShell workflow, service management automation, Windows Azure PAC, Service Manager, and the self-service portal to really automate a lot of things that are really boring in your teammates' jobs and ultimately get them working on things that are of more value to the business. So thank you very much again for having me out here. It's been a pleasure. I hope they'll ask me back next year. We'll see. But thank you for listening. And I'll be around today if anybody has any questions on this as well. So thank you.